Hi, I'm Erica Mabian. I'm the iSpark CTE Coordinator with Kansas City Public Schools, and welcome to KCPS Homeroom. Today I have an exciting presentation for you. We are going to go on a field trip. Yes, a real live virtual field trip. The exhibit that we're going to finish seeing is at Science City. The exhibit is called Every Last Drop. And in the end, we're going to have a design challenge that's going to cultivate all of our learning and all of our thinkings and all of our wonderings as we have been along this journey. So let's get started. Our objective today is going to be to develop plans that describe a program sequence of events, goals, and expected outcomes. What do you think we're going to be doing in the end? You guessed it. We are going to make a computer program. Yes, we are. All right, so here's your directions. After viewing our virtual field trip, the students will show and create a contraption that's going to collect clean snow. I know you're excited for it to snow the next time, and I want you to be ready. You are going to demonstrate how your plans are going to happen that you're going to use to create your snow collector. So you need to make a detailed drawing of how your project is going to look. So that's the first step. Draw a picture and plan it out. And then last, you're going to compare your collection of the snow that you're going to do versus how they collected water on every last drop. And see how they collect water versus how you're going to collect your snow. Then you can analyze your results of how it happened when you collect your snow and determine if you want to make modifications to your thing that you make, or if you need to go with it and see if your snow is not contaminated. All right, welcome to Science City. Enjoy this virtual field trip. Welcome to KCPS Homeroom, and today we're at Science City. You'll be able to visit Science City with your parents, and all the young inquisitive minds can come and create, explore, and experiment with the world of science through interactive activities and non-stop fun. There's nearly 100,000 square feet of indoor and outdoor experiments, exhibits, and activities. There's something for everyone to do, from the youngest of learners, including 4 new spaces dedicated for early childhood through infants to 6-year-olds.
Engage in the learning of every last drop. This interactive exhibit entices discovery and curiosity. Gravity makes water flow down and ultimately takes the path that it can flow. Here's the Archimedes screw. It's a form of positive displacement pump. The vortex, when the fluid is traveling around the hole, you can start to see it twirl around in that hole. We're moving over to the water table. You will see it uses slits that are able to manipulate the direction that the water is flowing. Balls and rubber ducks are then used to show where the water is flowing. When the water flows over sand or soil, it picks up pieces of that sand or soil and sometimes sediments that move it to different locations. Our water molecules are hanging from the ceiling to represent the individual water molecules and what they actually look like. Here's our table again. It helps to show the flow of the water in whatever grooves or indentations that are in our earth surfaces that constantly reshape and make those paths and the grooves that makes the water move along. You could change the slits to change the path and see how gravity takes water in a different direction. Why do you think it's important to recycle water? Do you think that we can use clean water before it's used again? And what are the limitations that we have for filtering clean water? We can use rocks and all different types of ways to filter the water. Let's take a look at all the elements of every last drop. There is the Archimedes screw again. It is able to force the fluid down as it moves along the spiral or the helix. Being able to predict the direction of the water and how it's flowing helps it be necessary so that we could find a clean water source. Here's a fun fact. Bacteria is used to clean water. Did you know that? Because they decompose dangerous chemicals, organic matter that may be in water, and so they use the bacteria to help us have healthy, clean water. How about this? Water has been recycled for civilization since the Bronze Age. And lastly, wastewater was originally used in irrigation water and to fertilize crops. Humans have been trying to purify water for thousands of years. Now, science of the season, the theme for December. Here are a few of our activities. Here comes Santa Claus air pressure. Watch Science City educators demonstrate how high to low pressure systems push large loads like Santa through narrow chimneys. Next, make and take fake polymer snow. Work with super absorbent polymer like the ones used in astronaut diapers. And finally, sew a snowflake cord keeper. While our Maker Studio educators will teach them basic sewing skills.
All right, we just finished our field trip. That was so exciting. I'm so glad you got to come along with me. You're all ready to go with your family and explore all the things that every last drop has to offer. Did you notice the ceiling? I hope you did. We're going to talk about that in just a few seconds. So now that you've gone on your field trip, think about all the things that you saw at every last drop and how you can use all of that wonderings and all of that learning in order to make your own snow contraption. All right, so at every last drop, there's a few things that I want to draw your attention to. Did you notice the ceiling? Those were just not ordinary light bulbs. Those were something that you see every day. You drink it, you bathe in it. It's water. Exactly. And if you notice, it has a blue outer shell and two small white bulbs on the end. So what do we remember about the scientific way that we say water? That water molecule is a hydrogen and oxygen. How many of each? Let's think. H2O. Yes, you're right. It has two hydrogen atoms and one oxygen. So that is why it has two white on the blue. That was so incredible. And I was so glad to see that and experience that while I was at every last drop. And another thing that I wanted to draw your attention to is the Archimedes here. When we looked at that, it started to turn and rotate on the vortex. And the helixes that's in the middle of that cylinder, it captures all the water as it turns and allows the water to travel up against gravity. After it's at the top, it's able to fall down into the appointed receptacle. And then they have this item here in the middle. When I went to go film that, I was really nervous because it's a hollow vortex and I did not want my phone to fall inside. But when I looked inside, I was so intrigued. It just went round and round and round. Did it remind you of something that happens in nature, like a natural disaster? I thought it looked like a tornado. Have you ever made a tornado inside a 2-liter bottle? Maybe you can make one at home. And then finally, we had other different types of receptacles that we got to see at every last drop, including the water table. I really liked watching the water table for all the ways that it showed how the directions that the water could go and travel based on the stilts that were there and how we can change that, and that's just what happens in nature. Alright, so now we're ready to plan out our receptacle to collect snow. The first thing that you're going to do is create a drawing. It can be a quick draw. It doesn't have to be perfect because it's just getting all of your ideas onto paper. After you get a chance to look at your drawing, then you're ready for the next step. Alright, first we walked through the entryway of Science City. Then we went over to the train table, and finally we got to the every last drop. When you got there, what was the most intriguing thing that you saw when you were on the virtual field trip? Take some time to remember all the waterways and how it was collecting the water, how it transported the water, how it put the water in the right receptacle. Think of how you may want to collect your water. All right, and now you're ready to make your project. Just think about you want to tell somebody, everybody, all about your adventures. Maybe you want to go in person, but you want to capture all of this on a game. Yep, that's right, you can make a game. You could use either Scratch or Scratch Junior. You're wanting to use scratch.mit.edu, or if you have a tablet or an iPad, you can use the Scratch Junior app. So let's think about how we're going to make our story on our app. We have our written story. You wrote down all of the things you remembered from your field trip. Then you think about your setting, your characters, and your plot, how you want your story to go. Think about all the elements that you may want to include in your story. Then you're ready to get started programming. This will be geared for any age group that wants to do the programming. If you're using Scratch Junior, you're wanting to have someone that is able to follow the arrows because that programming uses arrows. But if you have a reader, you're able to use the Scratch. So I would say K through 2 for our Scratch Junior and 3 through 5 for our Scratch. Let's continue. Now, we're going to have a quick review of what we learned today. Today, we use our virtual field trip to describe a plan that we could do a sequence of events. Maybe we had a goal in mind. We wanted to tell someone about our virtual field trip, and we had expected outcomes. We wanted to teach them all the things that we learned. So, how do you start your program? First, you choose your background. Decide where you want to start. You could make one of the backgrounds that they have there with a plain sheet of paper, or you can choose one of the ones they have available for you. You are able to edit those as well. They have fall, winter, spring, indoor, outdoor, country scenes, city scenes. Your background options are endless. Then you're ready to add your character. You may choose a character that is already pre-programmed in the Scratch Junior apps, but if you're doing Scratch on scratchmit.edu, you are able to upload your own picture. So try doing that so it could be a little bit more personalized. You can add your family members, or you can add fictitious characters that are along and included in those programs. And then finally, the last step is to animate. You can make a real live virtual trip of your own in your computer program. Have your characters talk about the exhibit and all the things that they learned to do and learned about the exhibit. Maybe you're going to teach them about those water molecules. The H2O is the way to go. And finally, tell somebody, show somebody, have someone experience your program. You could share your program with us. You could tweet it out and make sure you hashtag KCPS Homeroom. You could tag me. I'd love to see your designs that you make with your computer program. Don't forget to go and see Science City. They're open and ready for you to explore and learn. And you can keep your learning going along this virtual way or in person and tell them that you're ready to find all about every last drop. This has been Erica Mabian for KC Public Schools Homeroom. Thank you so much for joining us, and we will see you next time.